everyone, today's more of like an extra practice type of day on simplifying trigonometric functions. So I want to go over a few strategies for simplifying expressions. First off, look and try to change the expression into sines and cosines. We did that yesterday. Also look for known formulas or actually force them to occur. So if you hypothetically notice, hey, it's a difference of two squares, treat it like one. Number 3, if there are fractions, make common denominators so you can add or subtract fractions. Number 4, use algebraic manipulations like factoring, distributing, pretty much anything you can think of that's an algebraic equivalence, go for it. And number 5, if a strategy or a substitution is not going anywhere, honestly, crinkle up that piece of paper and toss it to the side and just try to start something new. All right. As we progress into some of the more difficult things, you're going to see that some of your ideas lead to nowhere, or you just are making the expression more complicated. So no shame, try again. All right. I don't expect you to be perfect, but I want you to be able to try something new sometimes. All right. So quick overview. There's the identities that we've talked about so far. We will be adding to our identity list in the near future. So just some extra practice problems so you can see some of these algebraic manipulations. So in number 1, we're going to be simplifying that expression with 1 minus cosine of theta times 1 plus cosine of theta. And I take a look at that and I say, hey, that looks like something got factored. All right. And one option is to distribute it out or refoil it. You can also notice for sure that that is the expansion of a difference of two squares. So we're going to end up with that. I'll treat it just like a FOIL. You get 1 plus cosine of theta minus cosine of theta minus cosine of squared theta. And you see your cosine, your positive cosine of theta minus cosine of theta drop out, and you're left with 1 minus cosine squared of theta, which is your difference of two squares, which you should be able to identify as a Pythagorean theorem identity. So remember, sine squared theta plus cosine squared theta is equal to 1. So what would that look like? That is just use subtracting cosine squared of theta on both sides, and that is equal to sine squared of theta. And you're done with that one. Moving on to number 2, we've got cotangent of theta plus tangent of theta. So for this one, I look at maybe I should just switch everything to cosine and sine, so we're all in the same kind of thinking. Maybe things will drop out. So you've got cotangent is cosine of theta divided by sine of theta plus sine theta over cosine of theta. Now, you've got fractions. So we need to make common denominators in order to add these two fractions. So our common denominators, common denominator should be sine theta times cosine of theta. So in order to get that, I need to multiply the first fraction by cosine of theta, and then on my second fraction, I'm going to have to multiply by sine of theta, numerator and denominator. So that gives me, I'm going to add across the top. So you've got sine of theta, cosine of theta as your common denominator. And cosine theta times cosine of theta is just cosine squared of theta plus sine squared of theta, which you should be able to recognize your Pythagorean theorem identity, which is 1 over your sine of theta, cosine of theta. Now, this can technically be simplified a little bit further, but I like to go over this problem right now so that you can see how we make common denominators. So this will be to be continued when we learn our double angle identities. Okay, oops. So sorry to leave you hanging there, but you get to see the beginning techniques before we add some more. Number 3, we've got cosecant of theta plus cotangent of theta times cosecant of theta minus cotangent of theta. To me, I look at that, as difference of squares. So you can expand that out as cosecant squared of theta minus cotangent squared of theta. Okay, so now I'm like, do I switch to all sines and cosines and then maybe subtract fractions? Yeah, you can do that. But something that I noticed, I look at cosecant squared of theta, and I know that Pythagorean theorem identity of 1 plus cotangent squared theta is equal to cosecant squared of theta without having to make any fractions with sine and cosine. All right. If you did that, go for it. Great. You're going to get the same answer. So there's many roads that lead to the same simplified expression. So whatever you see, run with it. I see cosecant squared of theta is equal to 1 plus cotangent squared of theta, and bring down the minus cotangent squared of theta, and that makes for a nice clean answer of 1. Number 4, we're getting a little bit more complicated, right? So in the numerator, it's actually similar to the problem we just did. We got cosecant squared of x this time minus cotangent squared of x. So using the identity of 1 plus cotangent squared of theta is equal to cosecant squared of theta, I'm going to take and replace my cosecant squared of x as 1 plus cotangent squared of x. And then I think of my negative angle identities, and I go sine of negative x. Well, that's equivalent to negative sine of x. And what else can I do? I see a cotangent. I could switch that maybe to cosine of x divided by sine of x. I'm going to leave this cotangent because I can see something happening with that cotangent. All right, so in my numerator, I have 1 plus cotangent squared of x minus cotangent squared of x. So we're going to be able to drop some stuff out of there. Negative sine of x multiplied by cosine x over sine of x. All right, now we get to cancel. So cotangents drop out. We've got sine of x's drop out. And we're left with 1 over, what's left? Negative cosine of x. All right, so you could leave it like that, or I would also take negative secant of x. All right, and kind of like just the last one for today. Cosine squared of x divided by cotangent squared of x. I'm just going to switch that cotangent squared, see what happens. So cosine squared of x over cosine squared of x over sine squared of x is equal to cosine squared of x. I'll write it side by side so I can multiply by my reciprocal eventually. So cosine squared of x over sine squared of x. Okay, multiplied by the reciprocal. cosine squared of x multiplied by sine squared of x divided by cosine squared of x, and you see that drops out real nice, and you're left with sine squared of x. So some of these are going to look super familiar, some of them are going to be a little bit easier than others, and sometimes you might go down a road that makes things more complicated than maybe your friend would see, but it doesn't mean you're wrong, all right? So keep practicing this stuff for the next few days and we'll move on, all right? I want you all to have a great day, and I'll see you